Alright, today I want to talk about 8.12 congruent figures. And the first word I want to talk about is this word congruent. It's kind of like equal, but it means a little bit different than when we talk about it in math. So let's quickly compare and contrast congruent and equal. Now, congruent we typically use for shapes, or any kind of geometric construction that we can make. And equal we usually use in equations. And I would say that equal usually means that the values are the same between two quantities. For example, the same between two quantities. I could say that 6 is equal to 6. Or I could say that 12 is equal to 2 times 6. The value of these two sides is equivalent. However, with congruent, we usually mean that two things have the exact same shape and size. And that isn't necessarily true over here in equal. Now, if you look at my two 6s, they are not exactly the same. I can see that the shape is slightly different. I drew them separately. So they're not exactly congruent 6s. They're not exactly the same. However, they are equal because the values are the same. And that's kind of the difference between congruent and equal. And we often say that with congruent shapes, they have all the sides are equal and all the angles are equal. All right, let's make two congruent shapes quick, and let's take a look at the things that we can do when we know that they are congruent. For example, let's take this triangle and this triangle. Now, of course, when I draw them, they're not going to be exactly the same. But what I can do is I can add those notations in to show that they are exactly the same. I can say that this side is equal to this side is equal to this side, and this side is equal to this side. And those marks denotate which things are equal. Now, if I were to measure them exactly, they're not. But once I put the mark here in my triangle, it is true. And I can say that they represent two congruent triangles. Now, once they're congruent, I also probably want to put my little angles in. I can do that too. I'm going to use a different color. This angle is going to be equal to this angle. This angle is equal to this angle. And finally, this angle is equal to this angle. Now, I only used one tick for all of them, but because they're different colors, I was able to denotate them equally. I hope the different colors show up on there. It looks more clear when I look at it here in the light. So, what's the point? Why do we care? Well, here's what we can do once we decide, or once we can prove that two things are congruent. For example, say I have two rectangles. They are congruent. And I know that this side is 4. This side is 12. And I could say, I know that this side is 4. Well, what is that side? Well, I know that it's congruent, so I can say that the corresponding side here is going to be the same. So if I look at my rectangle, I can say that both of these are corresponding because I know that that is the smaller side of the rectangle, so they must be equivalent. So this is 4, so this is 4. This side corresponds here to this side here. So I know that it is also 12. And because of the rules of rectangles, I know that opposite sides are equal. So I know that this side is going to be 12. And those are the tricks that I can use to figure out if things are congruent. Now, it starts to get more and more complicated as I go. And in fact, what will start to happen is, say I have a triangle. Now, I cut this out just because it was a little bit easier for me to move around. And say I have another triangle. Now, these I did cut out, so they should be pretty close to congruent. But the thing to remember that's key is that the orientation or the direction that they are does not need to be the same. So I can put these two triangles, if I line them up, you can see that, yes, they are congruent, or almost exactly congruent. And I can then separate them and spin them around in any direction or any shape that I want, and I can say that these are still congruent. So I know that each of these sides is still equivalent to the other. For example, let's see if I can match it up correctly. This is correct. So I could put this side is equal to this side. This side is equal to this side. And this side is equal to this side. And now, no matter what direction I put them in, those shapes are still equivalent. It can get even more complicated if we have another shape like this. And I can even take that shape and I can spin it. And I can also flip it over. And as long as it works, I just have to figure out which side corresponds to what as I'm doing my solving. For example, say I have these two shapes. I would need to notice that here between these two, this one is shorter, so this one would be equivalent to that one, and this part here would be equivalent to this side. And in fact, it would also be true of angles. I could say that this interior angle here is going to be equivalent to this interior angle here. And this opposite angle here, which is directly opposite, is going to be equal to this side as well. No matter the direction that I put them in, and if I flip them back over, I would need to make sure that it's equivalent again. And that's going to be the key focus of this section. Let me see if there's anything else that I want to talk about or cover. The big thing is making sure that they are matching up correctly, and all of the things that we talked about have to be true. If there's something that I missed, or if you're confused about something, ask a friend, ask an adult, or search online, and good luck.